The distortion of the final molded product that comes out of our mold is always something to be studied from a QA standpoint and also from a pre-molding standpoint. The first case study from Dr. Schneider shows us a lever for a fuel filler module, and we can see that there's a clamshelling effect. This distortion causes the mounting port for the rotation axis to be off kilter, which is functionally unacceptable for this molded parts application. From the simulation, we can see that there's a high amount of heat accumulation causing the shrinkage of the thicker region in that clamshell area to be much higher than the rest of the geometry. The solution here was to drop the wall thickness in that area from 2 millimeters down to 1 millimeter. This will allow the heat to escape more efficiently from our geometry and will reduce the local shrinkage in that area. Here we can see that changing from 2 millimeters to 1 millimeter decreases the warpage magnitude by about 40% and gives us a much more feasibly acceptable model. The second case study here from Westfall Technic is an automotive button housing with 50% glass fiber. The distortion on this part is understandably quite high. The first thing to look at in this case was the cooling circuit. We wanted to get something that was more efficient rather than just a generic circuit going around the outside of the mold. After improving the cooling circuit, we can see a significant reduction in the amount of distortion in our part geometry. But that wasn't the end of this project. Once the cooling circuits were optimized, we can then look at the molding process to see if we can optimize the warp even further. Once we were able to optimize the process, the customer then adjusted the dimensional tolerance of the part so that we're overcompensating to the steel safe side. The final molded part is exceedingly acceptable, and the parts coming out of the first mold trial from the aforementioned changes were within tolerance.